I don't think people realize just how much the hydrogen spectrum actually reveals about the inner workings of atoms. It's not just a topic for exams. This is the foundation of modern atomic science, and it's way more fascinating than most people think. The story of the hydrogen spectrum is like a detective tale, where simple observations led to revolutionary discoveries about the universe. Today, I'll take you on a journey to see how those seemingly simple colored lines, those bright glowing streaks you see in a lab, completely changed our understanding of atoms and the structure of matter. These lines aren't just pretty colors, they're clues that unlock the secrets of the atom and pave the way for quantum physics. Ready? Let's dive in. Hydrogen is the simplest atom in the universe, just one proton at its center, and a single electron whizzing around it. It's the building block of all matter, and yet it holds mysteries that puzzled scientists for centuries. Understanding hydrogen is like holding the key to the atomic world. When we zap hydrogen gas with energy, using electricity or high voltage in a glass tube, it starts to glow with a beautiful, almost magical light. This isn't just a party trick, it's the first step in uncovering the atom's secrets. But here's the twist. When you pass that glowing light through a prism or a spectroscope, instead of seeing a smooth rainbow like you do with sunlight, you get a series of sharp, distinct lines. It looks almost like a barcode you'd see at a supermarket checkout. This is what scientists call a line spectrum. It's completely different from the continuous spectrum you see in sunlight, which is a smooth blend of all colors. The hydrogen spectrum is made up of just a few bright lines, each at a specific color or wavelength. So, what causes these mysterious lines? Why doesn't hydrogen just glow with all the colors, like a rainbow? This question stumped scientists for years and led to some of the most important breakthroughs in physics. To understand this, imagine the electron in hydrogen as a kid playing on a slide at the playground. When the electron absorbs energy, it climbs up to a higher energy step, just like a kid climbing up the ladder. But it can't stay up there forever. It wants to come back down. When the electron slides back down to a lower energy level, it releases the extra energy it gained. This energy is given off as a tiny packet of light called a photon. Each time the electron jumps down, it emits a photon with a very specific amount of energy. Each slide, or jump, gives off a photon of a specific color, depending on how big the jump is. If the electron falls a long way, the photon has more energy and a different color than if it falls just a little. Different jumps mean different colors, and that's why we see those famous hydrogen lines. Each line in the spectrum is like a fingerprint, unique to hydrogen, and tells us exactly how the electron is moving inside the atom. The great scientist Niels Bohr explained this mystery by proposing that electrons orbit the nucleus in fixed paths, or shells, each with a specific energy. He said electrons can only exist in these allowed orbits, and no